And here we go. Welcome to day 9. I got a little bit of a late start, so I'm thinking I may be doing 2 parts today. But let's try out the problem and see where we get. All right, day 9. Day 9, smoke basin. These caves seem to be lava tubes. Parts are even still volcanically active. Small hydrothermal vents release smoke into the caves that slowly settles like rain. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a height map of the floor of the nearby caves for you, your puzzle input. Smoke flows to the lowest point of the area it's in. For example, consider the following height map. 2 blah 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 blah. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest a location can be. Your first goal is to find the low points, the locations that are lower than any of its adjacent locations. Most locations have 4 adjacent locations, up, down, left, right. Locations on the edge or corner of the map have 3 or 2 adjacent locations, respectively. Diagonal locations do not count as adjacent. Up, down, left, right, okay? In the above example, there are 4 low points, all highlighted. 2 are in the first row, 1 and 0. 1 is in the third row, a 5, and 1 is in the bottom row, also a 5. All other locations on the height map have some lower adjacent location, and so are not low points. The risk level of a low point is 1 plus its height. In the above example, the risk levels of the low points are 2, 1, 6, and 6. The sum of the risk levels of all low points in the height map is therefore 15. Find all of the low points in your height map. What is the sum of the risk levels of all low points on the height map? Okay, so let's go ahead and grab the puzzle input. It's huge. It's not that bad. Okay, so we're in part 1, puzzle input, and let's say the first step is going to be a height map, right? So we'll do this, height map.rb, and in spec we'll do height map spec.rb, and require our spec, require relative height map.rb, and describe height map. And then all we really need to do is, first goal is to find the low points, the locations that are lower than any of its adjacent locations. So then we just need to get the list of low points. And so to do that, we'll do describe low points, and it is, where's the list of them? 1, 0, 5, 5. I guess the order doesn't really matter, but okay, and so it's going to be lines. We do need a test input file because it looks like we're splitting the lines up. Okay, height map spec, and so we'll do give myself a little bit more room here. Okay, so height map equals file.open read I guess we can do it here. It's an array of arrays. Okay, so read.split on new line. And then we'll map line.split on character. And so now we've got, now we should have an array of arrays of integers. And then what we want to do is do test, map file, height map data, test height map equals height map.new height map data, and then expect test height map dot low points to equal an array of 1, 0, 5, 5. Cool. So let's do some basic setup here. Class height map, def initialize height map data, and def low points. And let's run RSpec. Cool. That's not good. I need to actually tell it what file we're opening. Go out of the spec folder and do test input. Cool. Nope. Why not? No such file dot slash test input. Did I spell it wrong? No. Save, yeah. No such file or directory. Nope. That's relative to where I am. Okay, that's fine. Well, it's kind of not fine, but that'll have to do. Cool. So we've got that, and then we do height map data equals height map data, and then we have low point or points equals an array, and then do at height map data dot each do row dot each do column, and then for each of these we'll do height map data don't need to do each with, we really just need to do height map data dot length dot times do row, and at height map data sub 0 dot length dot times do column, and then we just check up, down, left, and right. And we can do a couple private methods here. Def lower than up. if I can just do row column, and then what I would want this to be is points height map data sub row sub column if lower than up row column and lower than down row column lower than left row column and lower than right row column. So we just add the points to the points array and return the points. And so here we just copy all four of these methods. And if it's lower than up, and so this is if it's top row, if, let's see, return true if row equals 0. Lower than left is return true if column equals 0. Lower than down is return true if row equals, so what is that? Height map data dot length, and this one is return true if column is equal to height map data sub 0 dot length. And so now we can do now we need to check the value. So if we do value equals height map data sub row sub column, and that's going to be the same thing we do for all of these. Let's give ourselves a little space here from that turn. And then what we want to do is return height map data sub row -1 column value less than that. Oh, actually, I don't even need to pull out the value. I can just do yep, okay, cool. And so if it's lower than down, it's +1. If it's lower than left, it's column -1. And if it's that, it's column +1. Or, oops, I need to actually do this part. Cool. So now our test should pass, I think. No. In comparison of integer with nil failed. On what line? 45? It's not clear. Our spec. Okay, so what do we have? We have column equals 0. We have height map data row subcolumn 2. Yep. Okay, so what I want to do is column or height map data sub row sub column, or let's say puts row column Okay, so 9, return true if height map data dot length. So what do we have for height map data sub 0? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Why wouldn't it height map data sub 0 dot length 10? Oh, so I need to put -1 there. Program, get rid of the pry. And we passed. Okay, so now it's time for bringing out the solution.rb. And we do input equals file.open./puzzle input, read split on new line, map line.split on character, map, turn them all into integers. We do require relative height map.rb, and then we do height map equals height map.new input and height map.low points. Let's see, puts low points. Let's see if we can do this by hand or if we need to solution. See if we need to do it by hand or can just eyeball it. Yeah. Looks like we're going to need to eyeball it, or we're going to need to do the calculation. Okay, so low points equals low, let's say, what is this? Risk level. Risk level equals low points dot map point +1 and puts total risk level equals risk level dot sum, and we've got 425. Hey, right answer. Now for part 2, which is going to, I assume, be pretty rough, but let's see. Next, you need to find the largest basins so you know what areas are most important to avoid. A basin is all locations that eventually flow downward into a single low point. Therefore, every low point has a basin, although some basins are very small. Locations of height 9 do not count as being in any basin, and all other locations will always be part of exactly one basin. The size of a basin is the number of locations within the basin, including the low point. The example above has 4 basins. Top left basin. Top right basin. It's kind of like, looks like whatever is bounded by a 9, huh? Yeah. Top right basin size 9, middle basin size 14, bottom right basin size 9. Okay. Find the 3 largest basins and multiply their sizes together. What do you get if you multiply together the sizes of the 3 largest basins? Okay. So we've got 1, 2, 3, that's 4 basins. And let's do this. So it looks like I don't actually need to use the second folder. I can probably reuse a lot of this, but let's create a solution2.rb to have some scratch file to work with. And what we want to do is describe basin sizes or basins. And we really just want to know the sizes of these basins. So we know we're going to have 4 basins, and we just want to do 3, 9, 14, 9. And we can copy the same height map data setup and expect test height map dot basins to equal 3, 9, 14, and 9. And what's interesting, it means that each low point does it mean that each low point is going to be its own basin? Therefore, every low point has a basin, although some basins are very small. Right. So really, you can't be... Well, I guess you could be a low point with... You could be a low point without... Two low points could be in the same basin, I think. Right, because it could go 5, 6, 6, 5, 8, 8, and this would be a low point, and this would be a low point. Oh, my mouse cursor isn't shown on here. Good to know. So probably what we would want to do is, if we calculate, so this looks like this test code doesn't have that as a case, but I suspect in the data we're going to, that's going to be important. And so to do that, we can just calculate each basin and check if any of the numbers are taken, or afterwards see if there's any duplicates and probably just call unique on it actually. And that'll take care of it, right? Right. So that's all. Or what happens if we do okay, so if they're not in the same order, that's going to be a problem. Well, maybe let's first do the calculation and see sizes, although the first one had quite a few low points, which means that would be a lot to look through by hand. And really, we kind of want low point. First thing we do is we need to know the low point positions. So let's change this to this, and low point positions equals, or row column. Okay, and is that still if one more end here? Cool. Undefined method basins. Okay. And it's going to fail because it's not the right answer, but we know that it's there. Okay. So now we want to do let's calculate the low points. And then we've got low point positions dot each do we call low points. We also have basin sizes equals array low point positions dot each do low point position, and then we need to check up, down, left, right. So here we do basin size equals 1, basin sizes, basin size. And then in here, we need to calculate basin size plus equals all locations. Number of locations up down, left, and right. And then same thing that we did here. Def number of locations up from point position sub 0, low point position sub 1, and put that on all of them. Row column. Down, left, right, right, left, down. And so if there's, it's similar to what we did below for return 0, if row 0, return 0 if row is equal to height map data dot length minus 1. And return 0 if column equal to 0, and return 0 if column equal to height map data sub 0 dot length minus 1. And so again, same algorithm. We'll do number of locations. Actually, we'll probably do number of locations equals 0. No, not. I guess I don't need to fix that, but let's do this here. And so now we do number of locations. We do while height map data sub row or sub current row sub column not equal to 9. Number of locations plus equals 1, and current row plus equals 1. While, or minus, so we're checking minus equals 1, and current row is greater than 0, and current. So we'll loop through, we'll add 1 to the number of locations, we'll decrement the row, we'll check and see if it's greater than or equal to 0, and then we'll return number of locations. Okay, and so we can do the same thing through here. We're not solving the case where we've got overlapping basins, but I imagine that's going to be a case, but I might as well see if the problem solves itself without that case. Current row is greater than height map data dot length, or is less than height map data dot length. This is current row equals row, height map data dot length, and at height map data sub current row sub column not equal to 9, and we increment number of locations, and we increment plus equals 1, and we return number of locations. And now we've got current column equals column, while current column is greater than or equal to 0, and height map data sub row current column not equal to 9, number of locations plus equals 1, and current column minus equals 1, and return number of locations. And let's do that for the right. While current column less than height map data dot sub 0 dot length, and height map IGHT map data sub row sub current column not equal to 9. Do the same thing. Number of locations, we're going to return that, and we're going to number of locations plus equals 1, and current column plus equals 1. So we've got that, and now we've got basin sizes, and let's return basins. 89. Yeah, I probably should use the close parenthesis. Undefined method current column. I didn't do that one. 89. Yep. Column equals column. Ooh. Oh. You can't call the method at the bottom here. Basin sizes. 17, 16, 18, 17. Okay, well, that is definitely wrong. Now, why is that? Let's see. So it'd probably be useful to see here what part of it is wrong. Number of locations. So we've got low point position 0, 1, so it's this top one here. We've got number of locations up from here. One, 0, right? Number of locations down from low point position sub 0, low point position sub 1, 5. That's not right. So why is that? So down looks like it's got a problem. Current row is less than height map dot length. Current row equals row. I think I might have them backwards, but still not telling me what is there's 5. We don't want it to go off the bottom. We don't want current row column to be 9. Increase the but when we increase by 1, it should go up by 1. So let's see where we're at here. What we've got is current row is 0. We got height map data. And at height map data sub current row column. Oh, well, that's why. I need to split that up. Did I do that? Yeah, I see. I did that right the other one, but did not do it right here. And that bug is probably going to cost me being able to solve it all in one part here, in one session. But let's try. Let's see if. Nope, that's all the prize. 5, 9, 11, 9. So that's getting better. I still have that first one wrong. Row column. Well, let's see if let's see which one's wrong here. I can just copy this too. Number of locations up is 0. Number of locations down from 1 should be 0 as well. That's 1. That's no good. Here 2, and here it's right should also be 0. Oh, no, not that one. This. Okay, so I think what might be happening is we're counting it one too many times. Okay, well, I'm kind of run out of time here. Got to move on to stand up, but made it through most of part 2. When we come back, we're going to try to solve this problem without that potential bug, and then find out we need to actually solve that edge case, and then solve that edge case. And I'll be back probably around 6 p.m. Eastern again today. If you watched, thanks for watching. I'll see you later.